Hi, my name is Charlie Crocker. Welcome, Facebook fans, to another AutoCAD Facebook Facecast. Today I have Stephen Hooper with us. Stephen is a product manager in our manufacturing group. Stephen, tell me a little bit about what you do.
So I'm the product line manager for our mechanical solutions at Autodesk. So I basically work with a team of engineers to make sure that we produce products for people who are involved in manufacturing and mechanical design of products.
Give me a couple examples of the type of customer or user. You know, what do they create using your products?
So our customers generally either are in industries like industrial machinery, where they're producing heavy engineering equipment, or they could be in the automotive or consumer product industries, where they're producing the products that you and I drive to work or use in the office while we're here.
I've been out and visiting a lot of customers, both in the AEC space and the manufacturing space, and it's clear to me that a lot of them are starting to use tools like Inventor, or they use tools like CATIA or SolidWorks. But they're also using AutoCAD, is that correct?
Yeah, that's true.
And what are they using AutoCAD for in those environments?
They're using AutoCAD for a range of things. It could be that they're using it for 2D documentation, or they could be using it as a very easy to use 2D layout tool for conceptual design and ideation at the early phase of the design process.
So in talking to customers like you guys, it's clear to me that when you get a model from, say, Inventor, or a model from CATIA, that can be really painful to figure out how to get that into AutoCAD, do the documentation. In many cases, I've talked to customers where they're completely redrawing the model in different phases or in different views.
Yeah, absolutely.
So I hear we've got something, a product set that may actually help us. What's that called? So
it's called Product Design Suite, and the intent behind it is to really remove that pain that you're talking about. So for our customers that are involved in a design process where they have to go through conceptual design, engineering, they need to be able to simulate and optimize that design. Perhaps they even need to be able to visualize it to sell it to their customers before they actually produce it. We talk about digital prototyping, and what Product Design Suite offers you is the ability to create that digital prototype in a virtual environment in one suite of tools where everything's connected.
I know about AutoCAD. That's what me and most of the fans here know about. What I'd like to do here, I'm going to go to the Product Design Suite site on Autodesk.com. So here's the Product Design Suite. We've got Standard, Premium, Ultimate. If we hit Compare here, we can actually see what's in the different suites. Okay, so the standard suite's got all the suites have AutoCAD.
Yeah.
They have mechanical, and they also come with Inventor. Every single suite comes with Inventor.
Yeah.
And then we get a lot of these great tools for simulation. What are these other tools?
So the easy way to think of Standard, Premium, and Ultimate is if your requirement is to create 3D models and 2D documentation, then Standard's probably the right tool for you. If what you want to do is take things a step further and you want to be able to build what we would call a complete product definition, so everything, the electrical systems, the control systems, the hydraulics, then Premium's the right tool for you. And if you want to do styling and you want to be able to do tooling for production, jigs and fixtures, injection molding, and high-end simulation, then Ultimate's the right tool for you. So we provide our users with a range depending on their requirements.
So for an AutoCAD user, somebody who's worked 80–90% of their life in AutoCAD, how easy is it for them to start using Product Design Suite?
Well, we try to make it really easy for them. So that's why we've implemented a thing called Launchpad. And that tool enables people who are new to Product Design Suite to basically tell the system what task it is that they want to achieve and have the system make the decision about what the most appropriate
let's look at that. So we're going to show you now, I think, Launchpad, right? And some of the tools and workflows that work in Launchpad. And what we're going to do to start this demonstration is to start on our trusty tablet computer here. I have my email here. I got an email from Stephen here earlier, and I'm going to press on the DWG attachment, and it says open in AutoCAD WS. So I'm opening it in AutoCAD WS. It takes just a sec to do the download, but it'll be up here. Once I have it up, we'll just see what it is we're going to be working on today. And then what I'll do is I'll save it from here, which will then save it up to the cloud automatically. So here it is. Looks like we're going to be working on a dump truck front loader.
Yep.
Front loader.
Yep.
So we're going to work with this front loader DWG, and so I'm going to save it right now to the cloud, and then it'll be available for me or for Stephen or for anybody. So I've received the drawing, and now we can work on it. All right.
Okay.
Okay. So what do you want to show us here?
Well, so obviously those, access to AutoCAD WS comes to our users as part of their subscription services. But now when we move back across onto the desktop and we start to want to do some engineering on my local computer, obviously I've got a range of different software in this suite of tools. I want to figure out what the best
Right. How do I know when
work.
to use electrical, Inventor, mechanical, that kind of thing?
That's right. So
You want to hit
2D Mix,
Yeah.
yep. So effectively what we'd start with is something that we'd call the Launchpad. And as I said earlier, what this does is it helps the user identify the type of task that they want to achieve rather than which particular technology.
So nowhere in here do I see the word, oh, I do see, there's some products. So here, reuse 2D data is to create 3D models in Inventor from 2D design.
That's right.
Okay, so the products are in the workflow, but they're not the focus of the workflow.
No, exactly. The user's task is the focus of the workflow. So in this case, what we want to do is reuse your 2D piece of data.
So the data that you sent me on my by email that I just viewed.
That's right.
Okay.
That's what we want to reuse. So we just tell it what piece of data that we want to reuse, and in this case what we want to do is reuse your AutoCAD drawing, so that's the dimensions and everything in there, but we're only going to want to focus on one particular part of that assembly that I sent you. So what we're going to do is just selectively choose the pieces of the drawing that we want to import, and because obviously we're based on the Autodesk DWG standard, you can see that we can work with DWG seamlessly. Select the data we want, select OK, and then have the system take care of it.
So here we are. Now it automatically opens up in Inventor. So we literally, I'm the AutoCAD guy. I just clicked on the reuse 2D workflow. It asked me for the drawing. I look at it, choose the pieces, and now we're in Inventor. So
it's actually taken things one step further, because it's not only translated the dimensions and the drawing geometry, but I can start to add intelligence to it now. So this is the beauty of working inside of Inventor, is that now the dimensions actually control the size of the geometry.
Right, so this is the dimension that came from AutoCAD,
yeah,
but we're now in Inventor.
So if I change it from its original size and round it up to 75, you can see that Inventor actually updates the geometry.
The model itself grew.
Yep.
That's great.
So it handles all of the associations necessary to...
In Inventor, people tend to work more in 3D.
That's right.
Okay, so how are we gonna do that here?
So it's really simple, Charlie. I mean, all you've got to do is use one of these tools to tell the system what you want to do with that 2D profile. And in this case, we just want to extrude it by 5mm. So we want to make that profile a 5mm thick plate. And it's as simple as just one mouse click and we're done.
So the other thing that I've heard about, I think it's in Product Design Suite Inventor, is if you're on subscription, you actually get access to like cloud-based simulation tools.
That's right.
So how can an AutoCAD user use Inventor as a tool to do simulations?
Yeah, I mean, firstly, there's an awful lot that's crammed into Inventor anyway in terms of being able to optimize a design. But what we wanted to focus on here with you this morning was the ability to use the power of the cloud to really amp up what you can do from a simulation point of view. So with this particular linkage, we want to figure out exactly what the optimal size for the linkage is to withstand the forces that we're going to apply to it. So we're going to use cloud-based optimization. And what optimization is going to do is it's going to look at the dimensions that are on the model, it's going to vary them to figure out what the best combination of dimensions are to solve the engineering problem.
So in a sense, we're going to take the model and bend it and stress it and figure out the best configuration.
Exactly.
But we're not going to do that on the desktop.
No, we're going to define what it is that we do on the desktop, but first of all we're going to tell it where the model's actually fixed, so we're going to choose the back there. And then what we're going to do is place a load onto the model, so we're going to tell it where the force that operates.
So at the top is fixed, at the bottom is you're going to have the pressure, and now we're going to figure out, okay, so what parameters are we going to test? How are we going to...
That's the next bit that we're going to do. So we can just select the model and it shows us all the parameters that are on the model, and I'm going to tell it that there's a range of different sizes I want to have a look at. So I want to see what would happen if we made that linkage 50mm.
So if this entire arm was 50mm or 75, and you could put in a bunch of these, right?
Yeah, exactly. I mean, it would be pretty easy to figure out just on my own those two values for the length.
Right.
But what happens if I start combining that variance with different thicknesses? So if I say, well, it could be 3 millimeters thick, or it could be 5 millimeters thick. So now what we've got are two parameters that each have two variants. So now there are 4 different combinations of linkage that we
And
can
you could
have.
do 10 and 10, or 100 and 100, and you very quickly get a lot of optimization.
Exactly. So now what I'm going to do is just start telling it to optimize this. So obviously I'm going to have to save this, and we're going to optimize it on the cloud. So I'll just save it with the name cloud, and it's now going to go off and start optimizing this on the cloud. And what that means is that it's going to take all of the information about the simulation, so the materials and the loads and all of the different conditions. It's going to package that information up, and it's going to place that information up on the cloud, where our parallel servers are all going to work on solving each of those problems.
So in the past, if I was doing this, let's say this is only 4, but let's say I ended up with like 36 different options, which seems like it'd be easy if you just did 2 or 3 parameters. In the past, how would I have done that?
So in the past, what you would have had to have done is worked on each individual problem. So you would have had to have changed the model for each individual problem. You'd have had to have reapplied the loads and then solved it.
So I would have said run 1, run 2, run 3, all the way up to 36. I would have done that myself. And then how do I know which one is the optimal output?
Well, then you would have had a real problem, because you would have had to have sat there and gone through all 36 results to figure out which one was the optimal one. And obviously that's probably not too bad with 36 results. But it could be that 5 or 6 of those results were very close together, and there wouldn't have been a clear-cut way of being able to make a decision.
Right.
And it could be that in some cases you might have as many as, I don't know, 1,500 different results. Firstly, you wouldn't have had the time to have sat there and updated the model for each of the 1,500,
right,
and then going through those results and figuring out what the optimal...
So our little one here doing 4 is a good illustration, but
Yeah.
when you're really dealing with a lot of pieces, this is just one piece.
Yeah.
Of a product,
Mhm.
and a product's going to be made up of hundreds of pieces. So
Yep.
this could be very time saving. So let's go back here and see what the results are of the
That's it, you're on it.
of the optimization.
So what you should be able to see now is the original outline in black here is actually showing what that part used to look like before we ran the optimization. The coloured part is showing us the optimized part, so it's the computer's made the decision to shorten the part, and the colours are representing the different loads that are actually on the model. So if I animate this, we can see that by applying that load onto the model, we can see
You
what
can
different
actually
type
see
of
the
stress.
steel bending
Yeah.
and stressing.
So we can see where the major stress points are. And also what it's telling us most importantly is the factor of safety. Now the factor of safety is how many times stronger is this part than it needs to be.
So
before
you
it
would said the
breaks.
load on that was something like...
Yeah, it was only about 1.5 kilograms because it's for a child's toy. And
But,
we've
so
set
really
it-
it's 4.5 kilograms
yeah,
is what it's
3
optimized
times
for.
the factor
Okay.
of safety. So if I look at the results, what it's showing us here is that the original model would have failed. The model that we've optimized for, the optimal one, is actually 3.4 times the factor of safety. And not only is it stronger than it needs to be, it's actually reduced the weight by 20%, which means you're using less material. That's costing you less to manufacture.
Costing you
it.
less, it's more environmental.
Yep.
Yep.
So all in all, it's a good result. It's a good result for you as the manufacturer, it's a good result for your customer, and it's a good result for the environment.
So if I'm an AutoCAD guy and I've done the optimization here, and one of the things I need to do is communicate the results of my design, right? So, and we usually do that through 2D documentation.
That's right.
So how do I go from here back to an AutoCAD environment and make sure that I have the most current version?
So I'm going to do exactly what we did right at the beginning of the little demonstration. Let's go back to the Launchpad and have that tell me what I need to do. So I know I want to create a technical drawing of this 3D model, and you can see that there is a task specifically designed for that. So if I ask the system to create a technical drawing, it's going to guide me through the process. So I may be that I've not really used AutoCAD.
So we're doing a technical drawing here.
Yep.
In the last one, we actually took a drawing file and we brought it into Inventor and started a project.
Yep.
Now we're literally saying, hey, I've got this Inventor project and I want to look at that in AutoCAD.
Absolutely.
So I know a lot of our fans actually do get copies of Inventor files or CATIA files. So you could do this also with
Pro Engineer, CATIA, Unigraphics.
That's great.
Pretty
That's
much
great.
anything.
Okay, so show us with the Inventor file though.
So in this case, I'm picking a template. So I know which template I want to use inside of AutoCAD, and then we're going to pick that cloud solved component that we were just working with. In fact, we'll choose this one. And then when I select open, what it's going to do is take the application that it knows it needs to use, which in this case is AutoCAD, take that particular component, and then we can choose whether we want shaded views and then what type of projected views that we want to create for our drawing. So rather than having to sit there and draft each individual view, what the system's going to do is just calculate those views from the 3D model for me. So I can very quickly just drop them out. And what's more, I get them shaded as well.
So this, I mean, if I had this Inventor model myself, I would have had to either export it as DWG or if I just receive the Inventor model, I'm not sure how I'd actually do that in AutoCAD right now. So this is, not having to redraw is huge.
It's a huge time saving.
Yeah,
exactly. And you can see that I'm just starting to document it now with just standard AutoCAD dimensionings.
Right.
Yeah, so you basically just carry on working with the system just as you always have done as an AutoCAD user. You don't have to learn how to do anything new. You can just work with the system as you always have and create your documented views.
So let's say I got the Inventor model. I did what I did here, and then somebody a couple weeks later runs a set of optimizations and actually discovers, hey, or maybe they do some product design and they don't like the look or feel, and they make some changes to that model.
Yeah.
Do I have to redo all my documentation?
Well, no, that's the beauty of this system. So what I'm going to do here is we'll just simulate that example that you gave us there. So I'm going to save this as the complete drawing, and we'll replace the one that's already there. And then I'm going to close it down because what you just described might take place over a couple of weeks.
Okay.
So let's go back to the Inventor model now. It could be 2 weeks later in the process. So let's just finish the optimization. We could decide later on that actually this component is going to take more loading. We could rerun that optimization, and it might turn out that actually we don't want to have the lightning hole that's currently in the model. So firstly, the first benefit is the great thing with a parametric model is that we can just go back, make changes to the original model, and it all updates. So
you just got rid of that hole that would have taken some of the material out and saved us money. So we're putting a little more material back in, but we've added strength.
We're increasing the performance.
So now this drawing file gets sent to me. Here I put it in my cloud account, and now I want to update my documentation. Do I have to manually run it again?
No, absolutely not. So basically what we would do now is just go back into the AutoCAD environment, open up our drawing, which was the complete drawing, and you can see seamlessly it's updated the drawing. We haven't lost any of our dimensions.
So the hole's gone, it's automatically done.
Yep.
And this was a simple example. I mean, you could do a lot more complex examples.
Absolutely. I mean, I chose this example because it's more obvious to remove the lightning hole, but you remember we changed the length of the arm? Well, we could change the length again and all the dimensions would update. We wouldn't have to re-annotate the drawing. So as a draftsman, this would really speed up your process dramatically.
So this is a huge, huge productivity tool. If you receive 3D models from Inventor, 3D models from CATIA, Pro E, Unigraphics, Rhino, any of these models you can bring into AutoCAD and very, very quickly stamp out these views, do annotations. That's incredibly powerful.
I think probably just as importantly as well, if you're an AutoCAD user and you're thinking about working in a 3D environment, you're not having to give up all of the knowledge and investment you've made in AutoCAD. What you've got is a system that complements AutoCAD rather than competing with it.
So this is also, I mean, go back to the Launchpad if you don't mind. It seems like with this Launchpad, this is a really good way for people who are incredibly comfortable with AutoCAD to start dabbling in understanding Inventor, right? Simply, without necessarily trying to consume all of Inventor's power.
And it may be that you don't do machine design. So what we've focused on is very mechanically orientated examples here, but maybe you make consumer products, plastic parts. So in which case you can change the Launchpad to suit the type of industry or products that you design. So it's extremely flexible and it meets the requirements of many different personas in different industries.
That's great. So I hope you enjoyed this. Love to hear from you right now and ask questions through our chat. We'll have Stephen here for a couple more minutes. So if there's any questions or comments, we'd love to hear them.
Perfect. So we do have one question specifically about the Launchpad. Stephen, maybe you can talk a little bit about some of the other functionality that it can be accessed through the Launchpad.
Yeah, sure. So, you know, we've already covered a little bit here today, but most of these tasks are fairly self-explanatory. If you look through them, you'll see that, you know, if we're working with plastic parts, we might actually want to create a mold and tool die design. Obviously, mold and tool die is part of the product design suite, so there's a task in here that would guide you through that process. It could be that you have control systems for maybe a consumer product with electrical wiring. Now, the product design suite includes AutoCAD Electrical to enable you to create your schematic 2D electrical designs. There's also a workflow here with the Launchpad to take that information out of the 2D electrical environment and bring it into a 3D model, so you end up with that complete product.
So if you were designing this mouse that I have here,
yep.
You could do the mold and the mold design,
yep.
and the die for actually punching this thing out,
yep.
As well as the electronics on the inside.
Well, actually,
So
let's take that as an example. So if we designed the Launchpad to kind of work top to bottom, left to right. So you'd probably start with a conceptual sketch. So we have paint programs as part of Product Design Suite to enable an artist to do some artist impressions of what this product would look like. Next, you might want to do some styling. So there's a freeform surface tool called Alias that's part of the suite. Again, we would guide you through the process of creating the surface models. It's actually technology that people like Apple use. Next, you would probably need to engineer the product. So you'd need to have the PCB boards integrated. You'd need to make the mechanical mechanism for the wheel on the mouse. You'd probably want to select materials that were ecologically friendly for the environment. And then you'd probably want to stress out the model to make sure you can, you know, take all of the structural loading.
Similar to the optimization that we did earlier.
Exactly.
Yeah.
You'd want to create technical drawings, visualize the product so that you could sell it in the marketplace, as well as being able to create the mold and tool die for production that we discussed and integrate the electrical elements of the design. So all in all, it's the whole process.
So if this is something that you do in AutoCAD today, with Product Design Suite, you could start to dabble in automating other parts of these workflows,
yep.
Which would be, you know, a great way to just start getting engaged with that.
Absolutely.
Any other questions? All right. So thank you very much for another great Facecast. Stephen, really glad to have you here.
Appreciate you inviting me along, Charlie.
And we will see you hopefully a week from today, Thursday, August 23rd, same time, 8:30 a.m. Pacific Standard Time, and we'll be talking about AutoCAD 2013 with the product manager, Rob McGuire. And we will have an opportunity to see some of the really cool new features and connections to the cloud with AutoCAD 2013. So thank you again, and we'll see you next week.
Thanks.